So today we're going to talk about StringBuilder. Why do we need it? What it has? And yeah. So let's start by creating a new project. I'll call this one StringBuilder Demo. It will be an empty project since we don't need anything there. And then first things we go do is we'll go to project structure, check, like choose Java version if we need to. I just will choose Java version 17, for example. And then we create here like new Java class. Let's call the string builder runner or whatever. And first things first, we check that it's works with a customary hello world. So we press this nice little green button from IntelliJ and it outputs correctly hello world. So now that we know that our program runs, we can start showing what we have. What is string builder? Why do we care? Why do we need it? Well, string builder came out of necessity, therefore as a alternative to string. So let me explain. For example, we have a string. Let's call it maybe something more sensible like fruit, and that is it. Now we can use it to print. We can work with it. That's good. But what happens if we wanna, I don't know, create like we wanna add to a string. So let's say for whatever reason we wanna create a loop. We want the loop to run till 10. Let's create some other one with string result. I'll remove these guys. String result, yeah. That's an empty string. So you see the string has nothing inside. And I'm saying at every single go of a loop, add to itself the current number. Maybe we'll start with 1 and run till 10. Yeah, add the current number and then also add like an underscore. And I will show you what are the middle steps. So like, let me just put it here. So at every step, I will print the current value and result. Yeah, let's run this. So you can see I was printing it every step of the way. At the first iteration was 1, because here it gets added 1, and then here it gets added underscore. So at this point, at the first iteration, it's 1 underscores and 2 underscores, and basically all the way to 10. And this is our end result, right? Now, the basic problem the string builder is trying to solve is that strings are immutable, which means every time you make any kind of modification to a string, we end up creating a new string. Now, normally we don't care, but what happened is here we created one new string, and here we created one new string. So every time we create a new string and overwrite, in this case, it like the value of the result to a new string. That means that every iteration of the loop, I ended up creating 2 new strings. One here, one here. And that means for the 10 iterations, I created 20 new strings. That's 20 new objects in memory that garbage collector has to keep collecting if at some point. And that's just kind of wasteful. And that is why that was one of the primary concerns. The idea was that what if we create a mutable version of the string? Some other class, so string we know is immutable, but what if we create another option, let's say mutable string, and it can have, it's basically we can tell it to start exactly the same. Whether I put it or not, it will start from empty string, but I can put it just so it's extremely obvious. And then I'm not gonna end up now creating new objects, because I will just use a nice append method, and I will just say, hey, append to its current element and append to it underscore. And at every step, I can call to string. If I call to string, which anyways is called automatically if you in println, um, then it's at that point it creates a new string, but only at that point. So if I don't do that, it will just keep doing this, keep appending to the same object. So this time we're only have created one object, and then we keep appending to it, and only at the very end we will turn it into a string. Again, toString is redundant in println because println naturally calls toString on every single object that you pass in. That like probably beginners don't really know this, but yeah, that's one of the qualities of println. Whatever object you pass in, toString is called automatically. That's why IntelliJ is calling it great, saying it's unnecessary, it's redundant because that will get called automatically. But somewhere else, like if you were trying to assign it to a variable and result from StringBuilder. So if we try to assign it to a variable, then toString is necessary because if you don't call it, this is a string builder, you cannot shove string builder into a string. The way you do it is you call toString, which builds everything that you've appended so far into an end result. And if it calls this, it will be exactly the same thing. So you see it's exactly the same end result. But the advantage was we did not create 20 new objects. We did not create a new object every time we called append. It was the same object. We always interact with the same object. The new was called only once. And because of that, we're much more efficient. So that's one primary reason why you would want to use StringBuilder. Sometimes you will even see IntelliJ will try to warn you. Let's say, like, let's go back and create something here. And let's again do result plus equals I, right? And you see IntelliJ is complaining. It's saying you're concatenating to a string. Consider using StringBuilder. So IntelliJ itself is telling you this. And I don't know if there's more information. Yeah, here. Uh, every string concatenation copies the whole string, which it doesn't explain here why, but that's the problem. You create new object every single time. That's why it's preferable to replace it with StringBuilder append or string buffer append. String buffer is the old implementation of string builder, but it has the advantage of being, again, for beginners, not relevant. I'm just giving you all information. It has the advantage of not of being thread safe. Disadvantage that because of thread safety, it's like locking mechanisms. Basically, because its methods are synchronized, it is more computation expensive. In a situation where you do not need to worry about thread safety, go with string builder. So exactly. So IntelliJ even shows you this exactly what we've been talking about. Instead of doing plus equals on a string, consider using append. And you can even use the IntelliJ's quick conversion, and it will convert this to string builder. So you see before it was string, then IntelliJ made a string builder, and it's pretty much doing exactly the same thing. It uses append to keep appending to a variable, and only at the end, if you need it, you convert it into a string, which is very handy. That is the whole point of string builder, or like main point of string builder. We want to avoid unnecessary, creating objects because maybe this loop would run a million times. Like imagine it runs a million times. If I no, I think it's even 10 million here. Imagine you create 10 million strings, 10 million new objects. The memory is every single object you create takes a little bit of memory. Then soon enough, your program is eating crazy amounts of memory because of strings. But with string builder, you don't have that problem because it all gets, you know, it's all very memory efficient because we're only using the same object. So that's why whenever IntelliJ or anybody else like sees that you keep modifying the same string, which normally happens in a loop, the string builder is a preferred choice. Again, nothing wrong with that. Like our modern computers are like usually have a lot of RAM. You will be able to just use string and run it a million times, and probably like nothing will happen. Not probably, I'm pretty sure. Uh, like nothing will happen. It just will keep running a million times and keep adding something here. That's not a problem, but would have been uh, string builder is much more efficient. So that's one reason to use it. But it's not all of the reasons. So now you're thinking, okay, yeah, great. Well, I don't care about computation at this level. Yes, but there are other reasons to use it, namely StringBuilder has a bunch of helpful methods. For example, very common task, somebody tells you, here's a string, A, B, C, D, E. Please reverse it. So I'll just show it to you. Reverse this A, B, C, D, E. Now, how are you going to reverse it? Well, one way to do it is create a for loop. We say I run from last index till the first index, keep it decrementing one by one, and maybe let's call this input, and then this will be result, and I will just plus equals to input charet I. So at every step of the way, I'm adding to the result variable the current character, and then I'm printing it out. Now we can check it out. And what's happening? Why don't I see anything? Oh yeah, man, wrong variable used. Input length. Bam. Yeah. Now you see it works perfectly. We did revert it, but you see how many lines we needed. Now imagine how much easier can it be done with StringBuilder. Let's create StringBuilder. StringBuilder. A new StringBuilder. Let's assign it to a variable of the same type, obviously, because we're in Java Vault. ABC. And then I will append the current the string I'm interested in. And string result 2 equals ABC dot reverse dot to string. That's simple. You can reverse it. There's a method for reversing, which does all the logic for you. You don't need any of this. And then you can print it. And you see that they both work exactly the same way, except this one is so much more comfortable. By the way, I just broke it down to separate lines just because I wanted to be friendly, like to beginners, so that you guys see every step basically separately, but you can write it nicely in one line. So you can put it here, you can put it here, and you see like I'm creating a string builder, I immediately, at the moment of creation, put the default, like initial value. I call reverse on the same line, and then I pull to string. By the way, this like calling methods on top of each other, using each time using the reverse, the return value of previous one is called method chaining. So new string builder returns me string builder. Before it gets assigned to result 2, I immediately call reverse on it. So at this point, it's reversed. And then it returns another string builder, the reverse method. Every method of string builder except to string, and substring returns string builder. Um, so a reverse call returns another string builder, and I immediately call toString on it. So you see this. So the first constructor obviously always returns the same type as itself, as a class. So that constructor returns a class, a type, which is string builder. Reverse call returns, you can see it like, do you see it's public string builder. So string builder is a return type. It returns another string builder, and then toString returns string. And that string I save here, and I immediately print it. So you can get it all done literally in one line if you would have wanted to, literally like this. And that is why string builder is so comfortable. It's just one of the many methods it has, and you can see that like you can do things that it would take you. Here you would have ended up creating 10, not 10, sorry, 5. So we're looped 5 times. Each time we do plus, we do an operation on a string, concatenation operation. We are, because this is the same as doing this, right? Just a shorter version, just so you know. So result, I'll comment it out just so it's clear. Result plus equals input. Let me just copy it. So this is a longer form of this. And so every time we create this, we're creating a new string of using the combined values of the two. And because strings are immutable, so every time there's a new string being created, that means we created 5 objects because this loop is run from the 4 till 0, 4, 3, 2, 1, 0. So that's five iterations. So 5 times we create new string. On top of that, we had the initial string, that's 6. And, like so many objects we end up creating. And here, it's one single object that's created. You do whatever manipulations you need to do, and in one line, and it's done. So that's just one of the many methods that you're just very comfortable. Another one. Let's just come up with some other ideas. So now you know how to do it. And it has it has all the other beneficial methods. Let me just create string builder again with the input. I'll just call it builder this time. And so just so you see, it has all the same comfortable methods that string has. So you see, maybe we can just, chart one. Maybe we'll do it like this, yeah. So you can see the difference. This one is string, this one is string builder, right? And you see that they will both have the same thing. We can do charat finds the character of that is under the index of 1, which is B. Then index of, for example, which would return -1 for anything that it doesn't find. But let's choose something that it will find, which is D. And again, index of D. Then I don't know what else. You can call lengths on both of them. And you can call substring from, I don't know, 0 to 2. And if I run, they will all work exactly the same way. So I hope you see it here. They all, like charat1 returns predictably B for both of them. Index of returns correct index of D, which is 3, because A has an index of 0, B has an index of 1, C has an index of 2, D has an index of 3. Length is for both of them is 5, because they both have the same length. Substring from 0 to 2 is, as you can see, remember the first index that you provide is inclusive, the second one is exclusive. So it takes all the characters from the index of 0 till the index of 2, but 2 is not included. So that's why it's A and B only. So I just wanted to point out that these all work exactly the same. And one more important thing, substring is the only method that substring and string are the methods that return string from a string builder. You know, those are important because reverse and append return and the same instance of string builder. And the reason is for that. It's actual builder pattern. Again, we're going a bit ahead. You don't need to worry about patterns, design patterns yet. But that's why it has builder in its name, because it's based on a builder pattern, which is just this, which is relatively simple. The methods, like methods that mutated return the reference to itself. Therefore, when you do input.append, oh no, not input, sorry, builder.append, I don't know, underscore.append, not underscore, just minus.append dot. All I could change them because each method kept returning another string builder. And I can reverse it and stuff like that. And yeah, and they all return string builder. So if I want to assign it, like, I don't need to assign it to a variable because builder2, because just the original object is just being mutated. But if I want to, I can again save it to another variable. That's not a problem. So yeah, another useful thing that string builder offers, which obviously string doesn't, is insert command. So oops, insert. If I want to insert something, let's say in the middle, which would be somewhere at index 2. So index 2 is C. Let's say we want to insert something right after C. Let's just insert underscore. Then just so you see it, and then I will print it. Then you will see that it's now it's AB underscore CD. Oh yeah. Uh, so that's another thing. If it's insert, it actually just counts instead of doing index, which is honestly misleading in my opinion. But if you want to insert something, then it counts how many variables it should count of, and then so it's not index two, it's 2 letters after, so basically one index less for whatever reason. And but yeah, I'm trying to say if you wanted to do it with a string, you would would be kind of complicated. You know, you would have to do something like uh, string changed equals input dot substring 0 to 2. Then you would have to do this, and then plus input substring from 2. So I hope this is clear. So first I get 0 to 2, that's AB. Then I do the minus, or yeah, whatever, let's keep it the same, underscore. And then I grab from 2. If you don't specify a second parameter, it just grabs till the end. So from 2, which is C, till the end. So if I print changed, it will be exactly the same. You see they're exactly the same. But you see, it's kind of less intuitive, you know, like you got to calculate substring before, then something in the middle, then substring after. Of course, you can do it, but kind of annoying. Yeah, same as insert, you have a delete if you want. Let's now delete. And you say, where do we start deleting and where do we finish deleting? So if we want to delete uh, underscore after we print it, we can do from, which index will be that? From 2 till 3. Yeah, I want to delete something from 2 till 3. Or maybe let's delete from 2 to 4. So it will be A, B, D, E. So out builder. Again, to string is absolutely optional. Yeah, I'm just calling it for the sake of like transparency. And you see it's became ABD. So after this, I'll remove this one so it doesn't mess with us. So we're just looking at these two as outs. First it was ABCD, was underscore, and then I deleted from 2 till 4. So from this second index till fourth index is not included. And yeah. And just to finish up on a nice line, another what I think is very comfortable method, but I think from JDK 17 they both have it. Yeah, I think string. Let's try it. String input equals star, and the out input dot repeat. Yeah, but they both have it. I thought only StringBuilder maybe has it, but no, they both have it. Yeah, but it's a nice little method to input builder, string builder, to know input builder. Oh, but it tells you which one to repeat. So we can do, which is not exactly the same. So if I want to add 3 underscores, that's comfortable because string can repeat itself. So if I want to add 3 underscores, I would have to do something like this, which kind of is similar. Yeah. Input. And this one just works like this. And yeah, you see they're both the same. Kind of similar. Yeah, but this one repeats what you provide here, and this one repeats itself. Yeah. If I remember correctly, repeat came from JDK 11. Yeah, since Java 11. So yeah, it's a nice little method from 11. And string builder came actually repeat from 21, so pretty fresh. Okay. Yeah, that's all there is to it that I wanted to show you. I hope this was, showed you all the thingy, all the useful methods of StringBuilder has. Again, StringBuilder is just there for comfort. You can do everything StringBuilder does through string, but if your loop runs a million times, well, you're going to create a million objects. That's not very efficient because every single object takes a little bit of space in your computer memory. And if you just keep creating them endlessly, well, at some point, sooner or later, I don't know, like you can't create them infinitely. At some point, your memory is going to run out, while StringBuilder is much more efficient because it's only one object that keeps, the amount of characters it's inside of itself. So it's like one big string, like anyway. Yeah. So yeah, hope it was useful. Hope you learned something. See you next time.